Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on binomial distribution part 2. Let us recall the previous presentation. In the previous presentation, we have introduced the binomial distribution and calculated the mean and variance of binomial distribution also. Binomial distribution is a discrete probability distribution. That means the random variable x takes finite number of values. And here, if x follows binomial distribution, then x is called the binomial random variable. And in binomial distribution, the probability of x successes is given by ncx p power x q power n minus x, where n is the number of trials, x number of successes, p probability of success, and q the probability of failure. And also we have derived the mean of binomial distribution as mu equal to np and variance sigma square is npq. So in the last session we have derived these two values also. Now coming to the present session, let us solve some problems on binomial distribution. The problem number 1. A fair coin is tossed 6 times. A fair coin is tossed 6 times. Find the probability of getting 4 heads. So here the experiment is given tossing a coin, and that experiment is repeated how many times? A fair coin is tossed 6 times. So given n equal to 6, the number of trials n is 6. And what is the probability of getting 4 heads? So here the problem is regarding the result head. So let capital X denotes the number of heads, and here success is getting head. So out of 6 times, how many times we get success? That's the question. So out of 6 times, we need to find the probability of getting 4 heads. So x equal to 4. And here we can use the binomial distribution if we have the values p and q. And what is p? The probability of success. Probability of success. Here what is the success in this experiment? Getting head. So probability of getting head, small p, is probability of getting head, which is 1 by 2 when a single coin is tossed. Similarly, if we have p, we can find q using the property the total probability is always unity. So 1 minus p, q is 1 minus p, which results as 1 by 2. Now let us use the binomial distribution. By the binomial distribution, the probability of x successes is given by ncx p power x q power n minus x. So here we need to calculate getting 4 times success. So x equal to 4 is out of 6 times, n equal to 6, x is 4, 6c4, p probability of success is 1 by 2, power x means 4, and q again 1 by 2, power 6 minus 4. So 6c4 is 6 factorial by 4 factorial into 6 minus 4 factorial, 1 by 2 power 4, 1 by 2 power 2. And this 6 factorial can be written as 6 into 5 into 4 factorial by 4 factorial, 6 minus 4 is 2 factorial, 1 by 2 power 6. So this 4 factorial gets cancelled, 2 factorial means 2, so this comes 3 times in 6, so the answer is 15 by 2 power 6. So which results as 0.2344. So this is the probability of getting 4 times success when a coin is tossed 6 times. Similarly, let us consider another problem. A die is thrown 6 times. So again, now the experiment is throwing a die, and that experiment is repeated 6 times. So again n equal to 6. If getting an even number is a success, getting an even number is a success. Find the probability of getting. Now there are 3 problems are given. At least 1 success, less than or equal to 3 successes, and 4 successes. So first of all, the number of trials n is 6. And what is the experiment here? A die is thrown. A die is thrown. Then what is the sample space? Sample space contains 6 outcomes, 1, 2, 3, 4, 5 and 6. Now, what is our success? Getting an even number. So, let E be the event of getting an even number. So, how many even numbers are there in the sample space? 2, 4 and 6. So, the set E is having 3 elements. Now, P, the probability of success. So, here X is the random variable that denotes number of successes or even number, getting an even number. So, this is our success. So, the probability of success out of here n of S is 6 and n of E is 3. Out of 6 outcomes, 3 are favorable for us. So, the probability of success small p is given by 3 by 6, again which results as 1 by 2. Now, let us use the binomial distribution. By the binomial distribution, probability of getting x successes is NCX P power x Q power n minus x. So, here we need to calculate different successes, probability of, for example, here in the third problem 4 successes, first problem less at least 1 success and second problem less than or equal to 3 successes. So, if you have the number x, you can find the probability of getting some number of successes using this formula. Here n, the number of trials, x, number of successes, p, probability of failure or success, q, p is the probability of success, q is the probability of failure. So, if we have p, we can calculate q also 1 minus p, which is 1 by 2. Now, the first one. Now, coming to the first problem, we need to calculate probability of getting at least 1 success. At least 1 success means it starts from 2 successes, 3 successes, 4, 5 and 6 successes. All these comes under this case. So, probability of at least 1 success means probability of x greater than or equal to 1, at least 1. So, we need to calculate from 1, 2, 3, 4 up to 6. Instead of finding all those probabilities, we can use the property 1 minus probability of x less than 1. So, 1 minus probability of getting successes less than 1. Less than 1, what we have? Simply x equal to 0, 0 successes, complete failure case. So, use the formula from binomial distribution. The formula is probability of x successes is given by NCX P power x Q power n minus x. So, 1 minus 0 successes, out of 6 times 0 success, 6 is 0, 1 by 2 power 0 and 1 by 2 power 6 minus 0, which is 6. So, if you calculate this value, this will be 1 minus 1 by 64, so which is 63 by 64 and the answer is 0.9844. So, the probability of getting at least 1 success can be calculated using the property that the total probability is equal to 1. So, x greater than or equal to can be calculated using 1 minus x less than 1. Similarly, let us consider the second one, less than or equal to 3 successes. Less than or equal to 3 successes. Second problem, probability of x less than or equal to 3 successes. So, that means x equal to 0, x equal to 1 plus x equal to 2. Because equal to is included here, less than or equal to 3, we have to add x equal to 3 also. So, sum of all these 4 probabilities, or else the same thing can be calculated using 1 minus x greater than 3 also, 4, 5, 6. So, let us calculate using this. So, 6C0, 1 by 2 power 0, 1 by 2 power 6, since n equal to 6. Next, 1 success, 6C1, 1 by 2 power 1, 1 by 2 power 5, n minus 1, 6 minus 1 is 5, 6c2, 1 by 2 whole square, 1 by 2 power 6 minus 2 is 4, and similarly 6c3, half power 3, half power 6 minus 3, that is 3. So, if you calculate all these values, simply here we can take 1 by 2 power 6 common. So, 6c0 plus 6c1 plus 6c2 plus 6c3. This results as 21 by 32, which is equal to 0.6562. And similarly, the next third one, getting 4 successes. The probability of getting direct value here, probability of x equal to 4. So, simply 6c4, 1 by 2 power 4 and 1 by 2 power 6 minus 4, which is 2. So, this is 6 into 5 by 2, 1 by 2 power 6. So, 15 by, so which results as 0.2344. So, like this using binomial distribution, simply by substituting the value of x, we can find the probability of x successes. So, here main things are P and Q, the probability of success and probability of failure, and number of trials n. If you know these values, simply by changing different values for x, we can find different probabilities. And here in binomial distribution, this n and p are the parameters. So, if you have these two, you can find any probability. Similarly, let me explain another problem. It has been claimed that in 60% of all solar heat installations, the utility bill is reduced by at least 1/3. So, it has been claimed that in 60% of all solar heat installations, the utility bill is reduced by at least 1/3. Now, accordingly, what are the probabilities that the utility bill is reduced by at least 1/3 in 4 of 5 installations, at least 4 of 5 installations? So, here first we need to understand the problem and note down the given, what is the given data and what is the required one to calculate. So, here first thing, the probability, what is given? The probability of the utility bill will be reduced by at least 1/3, that is given 60%. So, the probability of utility bill is reduced by at least 1/3, that is given as 60%, 0.6. That implies the probability of success is 0.6. And using binomial distribution, probability of x successes is given by NCX p power x q power n minus x. And coming to the first problem, 4 of 5 installations. So, n equal to 5 given and 4, x equal to 4. So, what is the probability of success? 0.6. That implies probability of failure is 0.4. So, now we need to find the probability of getting 4 successes. 4 times out of 5 installations, 4 times we should get the utility bill reduced by at least 1/3. So, probability of x equal to 4 we need to calculate using the binomial distribution formula. This is equivalent to 5c4, 0.6 power 4, 0.4 power 1. So, this is equal to 5c4, we can calculate this, and using calculator the final result will be 0.2592. So, direct value is given. Out of 5 installations, we need to get probability of 4 times success. So, simply x equal to 4. But the second problem you see, at least 4 of 5 installations. That means, at least means greater than or equal to, x greater than or equal to 4 of 5 installations. So, x greater than or equal to 4 we need. Out of 5 installations, at least 4 times we should get the power bill will be should be reduced 1/3. So, probability of x equal to 4 plus probability of x equal to 5. So, 4 out of 5 installations, 5c4, 0.6 power 4, 0.4 power 5 minus 4 is 1, plus 5c5, 0.6 is the probability of success, 5 times 0.4 probability of failure, 5 minus 5, which is 0. So, after finding this value, this will be 0.2592 plus 0.07776. So, the answer is 0.337. Here, as finding NCR value is well known to all, I am directly giving the numerical answer here. NCR is n factorial by r factorial into n minus r factorial, and using calculator we can find this 0.6 power 4 and multiply it by 0.4, and finally after simplifying we get the probability of at least 4 times getting power bill reduced by 1/3 in 5 installations is 0.337. Similarly, let us consider another problem. If 3 of 20 tires are defective and 4 of them are randomly chosen for inspection, what is the probability that only one of the defective tire will be included? So, here first thing is we need to read the problem clearly. So, if 3 of 20 tires, if 3 out of 20 tires are defective and 4 of them are randomly selected for inspection, then find the probability that only one of the defective tire will be included. So, here there are different numbers like 20, 3, 4, 1. First, you should know what these values indicate. So, out of 20 tires, 3 tires are defective. So, the given thing is out of 20 tires, 3 tires are defective. Why this information is given? To find the probability of a defective tire, that is 3 out of 20. 3 by 20 is the probability of a defective tire. So, let us consider small p as 3 by 20. That simple as small q is 1 minus p, which is 17 by 20. So, if you consider this 20 as the number of trials n, you will get a different answer. This 20 is given to calculate the probability of a defective tire. Out of 20 tires, 3 tires are defective. So, the probability of a defective tire is 3 by 20, and hence we can calculate q also 17 by 20. Now, how many are selected for inspection? 4 of them are selected. So, n equal to 4, the number of trials, because we need to inspect each tire. For example, let us consider the first tire, that is 1 trial, second tire, third tire, fourth one. So, 4 trials, n equal to 4. Only one of the defective tire will be included. So, that means x equal to 1. So, by binomial distribution, we have the formula probability of x successes is NCX p power x q power n minus x. We need to calculate one success, means getting one defective tire out of 4 defective tires. 4C1, p is 3 by 20 power 1 and 17 by 20 power 4 minus 1 is 3. So, a simple calculation that gives the answer 0.3685. So, in this particular problem, you have to clearly observe the given values. Out of 20 tires, 3 are defective. This information is given to find the probability of a defective tire. Then 4 tires are selected at random and we need to inspect all 4. That means the experiment here is the inspecting each tire. So, n equal to 4 is the number of trials, and out of 4, only one of the tire will be included. So, x equal to 1. What is the probability? Using binomial distribution, yes, we can calculate this. And similarly, determine the binomial distribution for which mean is 4 and variance is 3. For which mean is 4 and variance is 3. Here, we know that the mean of binomial distribution is mu equal to NP, and variance of binomial distribution is sigma square equal to NPQ. So, given mean is 4 and variance is 3, mu equal to 4 and sigma square equal to 3. So, using these two, mu equal to 4, mu equal to NP. So, that implies NP is 4 and sigma square is NPQ and sigma square is 3. So, and NPQ is 3. This is 1, this is 2. Let us divide the equation 2 by 1. So NPQ by NP gives 3 by 4. Here NP gets cancelled. So we got the probability of failure Q equal to 3 by 4. If you have Q, you can calculate P also. So P is 1 minus Q, which is 1 minus 3 by 4. So P equal to 1 by 4. We have the probability of success, and since NP equal to 4 and we have P as 1 by 4, now the value of N, the number of trials, is N equal to 16. So determine the binomial distribution with mean 4 and variance is 3. To find the binomial distribution, first the main parameters of binomial distribution are N and P. So that's why we have calculated P first, then using P, N is also obtained. Now what is the binomial distribution? The binomial distribution is given by, with N equal to 16 and all, probability of x equal to small x is 16cx 1 by 4 power x and 3 by 4 power 16 minus x, where x from 0, 1, 2 up to 16. This is the binomial distribution with mean 4 and variance 3. In today's session, we have discussed some problems on binomial distribution. So using binomial distribution formula NCX P power x Q power n minus x, we can find the probability of x successes. So using the given data N, P, Q, we can find this probability of x successes. In the next session, again we discuss some more problems on the same binomial distribution. Thank you.